Look around for a moment. There's probably a zipper nearby. It could be on your jacket, your backpack, your jeans, your suitcase, or even a cushion on your couch. We use zippers almost every day, yet most of us never stop to think about them. We simply pull the tab, and hundreds of tiny teeth instantly come together or separate with surprising ease. It feels like such a simple invention, but making a zipper is anything but simple. Every zipper has to be manufactured with incredible precision because even a tiny flaw can cause it to jam, split apart, or stop working altogether. Behind that smooth sliding motion is a carefully engineered production process involving specialized machines, durable materials, and strict quality testing. So how do manufacturers make something so small and reliable? Let's take a closer look at how zippers are made, right here, on History of Simple Things. The zipper wasn't invented overnight. In 1851, Elias Howe, best known for the sewing machine, patented an early fastening device but never developed it further. Years later, Whitcomb Judson introduced a similar design, though it was unreliable and often jammed. The modern zipper finally emerged in the early 1900s when Gideon Sundback redesigned it with stronger, more precise interlocking teeth. His improved design became the foundation of the zippers we still use today. The name zipper was later popularized in the 1920s, inspired by the distinctive zip sound it made when opened and closed. Before visiting the factory, it helps to know what makes up a zipper. A standard zipper has three main parts. First are the teeth, sometimes called elements, which lock together to keep both sides closed. Next is the fabric tape that holds those teeth in place and allows the zipper to be sewn onto clothing or bags. Finally, there's the slider, the small piece with the pull tab that joins or separates the teeth as it moves. No matter whether it's on a pair of jeans, a winter coat, or a suitcase, nearly every zipper works using this same basic design. The manufacturing process usually starts with the tape. Most zipper tape is woven from strong synthetic fibers like polyester. These materials are lightweight, resistant to wear, and flexible enough to bend without tearing. Large industrial weaving machines produce long rolls of tape that may stretch for hundreds of meters. During weaving, the edges are reinforced because this is where the zipper teeth will be attached later. These reinforced edges need to withstand constant pulling every time someone opens or closes the zipper. After weaving, the tape is often dyed into different colors to match the final product. Whether the zipper is bright red, navy blue, or simple black, the color is usually added before assembly continues. Next comes one of the most important parts, the teeth. There are three common types of zipper teeth: metal, molded plastic, and coil. For metal zippers, manufacturers begin with strips of brass, aluminum, or other metals. High-speed stamping machines cut and shape thousands of tiny teeth every minute. Each one must be almost perfectly identical, since even slight differences can prevent the zipper from closing smoothly. Once the teeth are ready, automated machines attach them to both sides of the tape with extremely precise spacing. Even a single tooth that's slightly out of place can cause the zipper to snag or fail, so accuracy is essential. The slider is manufactured separately, usually through a process called die casting. Molten zinc alloy is injected into steel molds, where it quickly cools into shape. The slider is then polished, coated if needed, and fitted with its pull tab before being installed onto the zipper. Finally, small top and bottom stops are added to keep the slider from sliding off. For jackets and other separating zippers, manufacturers also install a pin and box at the bottom so the two halves can completely separate before being joined together again. Within just a few minutes, separate pieces of fabric, metal, and plastic are transformed into a fully functioning zipper. Before a zipper ever reaches a jacket or suitcase, it must pass several quality tests. Factories repeatedly open and close sample zippers thousands of times to simulate years of everyday use. They also test how much pulling force the zipper can withstand, how smoothly the slider moves, and how well it performs after exposure to moisture, heat, cold, and repeated washing. Different products also require different kinds of zippers. Heavy-duty luggage often uses strong metal teeth, while jackets and backpacks usually rely on flexible coil zippers. Dresses frequently use invisible zippers that hide behind the fabric, while outdoor gear may use waterproof versions designed to keep out rain. Although they may look similar, each zipper is carefully designed for its intended purpose. The next time you zip up your jacket or close your backpack, take a second to appreciate what's happening. That simple motion is the result of more than a century of innovation, careful engineering, and precise manufacturing. From woven fabric tape and perfectly shaped teeth to durable sliders and rigorous quality testing, every zipper is designed to work smoothly thousands of times without us ever thinking about it. What's even more impressive is that this entire mechanism is incredibly small. Hundreds of precisely made parts work together in perfect alignment every time you pull the slider. Yet most of us never notice the engineering hidden inside something so ordinary. It's a perfect example of how thoughtful design can make a complex process feel effortless. It's another reminder that some of the most ordinary objects in our lives often have fascinating stories behind them. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.